Hello. Thank you, first of all, for watching this and for any future support that might come out of any of you after I'm done this and uploaded it. So, the intent behind this video is to kind of walk you through some as real world a scenario as I can think of in terms of programming, tackling a relatively decent sized project. We're not going to cover, basic concepts. We're gonna dive pretty deep here. It's gonna be long form, so expect approximately hour long series. Every episode that I try and do. The frequency of the episodes kind of depends on you guys and your feedback, and whether you like it or not, whether it's useful. Hopefully, it is. I believe that there are a lot of getting started tutorials, and there's not a lot of here's kind of what reality looks like in a big project. As even as a senior developer, there's really not a heck of a lot out there, especially not long form. You can get 15-minute videos pretty much anywhere, including tutorials, written tutorials, but I don't think anything long form. I'm going to try and keep it as real as possible. I'm not going to try and do a bunch of producing and editing or, keep things super professional. I'm wearing pajamas. It's Sunday. I don't feel like putting on super awesome clothes. You'll probably see my dogs in the background, and you might hear my 1-year-old running around. I've got planes that fly overhead. I will try to not let that noise get in the way too much. So I do apologize in advance. I'm trying to keep this lean and easy to repeat. But the basic premise in the series that I'm trying to build here is that you can watch me as I attempt to build out a project. And it will include my thought process, which I'll try and verbalize. And it will include tests that I attempt to take on, failures, successes. I'll try and dive into different methods of accomplishing things. Basically, I'll just do the best that I can to give you a decent picture into what it looks like when you're tackling a project that's not as simple as how does async await work in JavaScript. We're gonna try and build something real here. And you're going to be able to follow along. It will all be open source. I'll show you. I have a GitHub repo that's ready to go. I'm also going to try not to plan things ahead of time. So I've been purposefully avoiding giving what I'm doing too much thought, because I want you guys to see what it's like when you're trying to tackle something. So if I just come in and I've prepared everything for you, it kind of loses that flow. And it's not really as beneficial as it could be if you were kind of just watching somebody actually go through the motions. I'm just going to check my phone here. Okay, so trying to think if there's anything else I need to mention, but I don't think so. Okay, so what I'm also going to attempt to achieve is bare metal code. What I mean is avoiding libraries and frameworks as much as possible. Not because I have a particular issue with them, but I do believe that there are a lot, especially in web development, a lot of frameworks, especially in JavaScript. There are so many frameworks and libraries, and I mean, look at the NPM repo. You can pick stuff off the shelf and mishmash it together, and I feel like a lot of the learning opportunities are gone. So I want to use this as a process where everybody's learning about the raw programming languages that I'm going to be using without the benefit of somebody has already figured this out. If you're doing this in a production environment, of course, there's financial stakes to be considered in your time. So if you don't have to reinvent the wheel, you typically shouldn't, and you can pick stuff off the shelf and run with it. Save time, save effort, get to the end goal quickly, and you can all profit, hopefully, and keep a job for a long time. But this is a learning experience, so I am purposefully choosing a difficult route so that you can learn as I learn. Some things I'll know, some things I won't know, and again, I'll try and be descriptive. Okay, so I think I've blabbered on enough. What I might do is set up a little preamble descriptive text for the next episodes so that you can, everything I'm kind of describing in this first episode, you can kind of get a condensed version. I have my coffee. I have a scratch from my 1-year-old who does not understand that her nails are sharp. So I apologize. I kind of look like a mess, but okay. So, Koro. Board game. So I started out programming because I wanted to build a game. Have never done it. I feel kind of stupid. I want to build a game, honestly. I really do. It's a difficult area of programming to get into. Well, I shouldn't say that because I don't actually know, but it seems difficult from the things I've read. I follow a few game programming communities, like on Reddit, for example, and it does not seem like a very overly fun place. If you're going to take it seriously, there are a lot of sacrifices and issues with it. But I still want to do it. I love video games. I don't have nearly as much time as I would like to play them, but that's what I want to do. So I want to build an online board game, Koro. If you don't know what it is, let me show you. I'll skip over to this other scene. Okay. Let's see here. So yeah, this is kind of what, well, let's go to images. Yeah, kind of looks like this. So you've got money, you've got dice, you've got cards. That's essentially the nature of the game. Those are the components you need. And what you're trying to do is, as you play the game, you start out with an initial series of cards. And each card, maybe we can get a close up here. Yeah, each card at the top has a number, and it's associated to a roll of the die. So if somebody rolls the die or the dice and say gets a 4, and you have a flower orchard, then the card is activated because a 4 was rolled. And you can see that there are certain restrictions, like some cards can be activated on anyone's turn, which means that if anybody rolls a 4, then anybody else with this card can activate it. But sometimes it can only be activated for the person who rolled the dice. So like if you roll a 7 and everybody has a pizza joint, only you, because you rolled a 7, could activate the pizza joint. So there are certain things that you can do with the cards, gain more money, etc. But essentially what you want to do is you want to build these landmarks. Let's see here. I'm trying to get a good picture of the landmarks. Okay, so the landmarks are down here, more or less. You can see, I think there's 5. There's some expansions which add more landmarks, I believe. But you can see like these are under construction. You want to earn enough money to build all of them. So you start off not having any, and then you pay to have more. And each of these 5 landmarks gives you additional bonuses or features depending on the roll of the die or what's happening in a turn. So I'm not going to delve too much deeper into how it's played. We'll sort it out as we go through. Like you'll understand some of the rules because there's an aspect to the process that will make the rules pretty clear, I hope. Feel free to look this up. It is a very fun game. I do highly recommend it. It's great for even with just 2 people. My wife and I play it by ourselves, and we have a great time. But it's really fun with more people, so I do recommend it. And as far as I'm aware, there's really no online version of this, and I do think that the technology that currently exists in the web development space could allow for an online version where you can play couch co-op or with people online. So right now, then, what I'm going to do is I'm going to start working through the thought process behind what I want to do and why I want to do it. So I'll show you what I'm going to do here. Let me just... I'm going to use Sublime. And I'm going to open up my repo. Where is it? Here. Okay. So I've got a repo. It's on my personal GitHub page. And this is the starting point. I've got a master branch. And essentially, I think the intent behind this episode is to nail down some of the choices and paths that I want to take building out this game. So I've got a license. I picked, I think, one that where I can't remember which one it was. Maybe it was the one where I don't encourage you to make money off of this. I kind of want to build this so that it's free and public and people can enjoy it freely and no ads and whatever. Maybe maybe I'm getting it over my head. I don't know, but we'll see. And then we've got a README file, which is just here. And so what I'm going to do is I'm going to use the README file on the master branch to just start writing down some ideas, figure out a path. We'll dig into some solutions and potential, I don't know, aspects that we can tackle. So I'll switch over to Sublime and I'll go to the README. Okay, so let's just start with kind of like, what is this? An online, or I personally would like to also create a couch co-op version, digital, of the Machi Koro board game. Okay, awesome. Okay, so what are some of the, let's just get like some high level goals here. I'd like it to be cross browser friendly. I'm gonna get a little aggressive here. I'm gonna include IE11. I'd like it to be cross platform friendly. I think for couch co-op particularly, let's circle back to that. I kind of have a thought process for that. Let's circle back. What else? As leading edge in terms of programming language and techniques as possible. No frameworks or libraries aside from what's default in a given language. Honestly, I'm not a good designer. If anybody out there would like to contribute to the design or the UX, please reach out. I'll just leave this as a note too. What other goals? At least capable of 2 players. Okay. I'm not going to try and worry about 3, 4, etc. players. Okay, let me just answer a message here on my phone. Sorry, guys. Gotta answer the wife. Yes, you can do this. Okay, what other goals do we want? Okay, let's start there. So let's go with that. So let's consider what's something that's cutting edge. So let's go to technology decisions. Thoughts. Okay, so I would say one of the cool things that has recently been coming out in the last few years are web components. And I really like how web components work. I've worked a little bit with them. Essentially what it is, it's encapsulated JavaScript components with HTML and CSS built into them. So if you, yeah, okay. So it's kind of like everything you need in a single component just comes packaged into it. So essentially what you're doing is you know how you're using tags in HTML, like a body tag, or in, an iframe, or a p tag, or a script tag, or whatever. Well, you can create custom tags. And what web components do are pick up on these custom tags, and you define the nature of the tag and how it's rendered, and how it's styled, and what its life cycle is, and what the JavaScript functionality behind it is. So like if we go on to this GitHub and we look at one of the, not sure if this will show us exactly. Yeah. Okay, so so there's a little bit here. This is somewhat customized, but we can use this a bit to get the idea. So essentially what you're doing is you're actually extending. So if we start here, you're extending typically an HTML element, which is like the raw browser element, and you're defining specific customizable attributes of this element. So you can have an element that doesn't render anything on screen, that just has properties inside of it, and maybe it does, I don't know, maybe it does some mathematical calculations, and that's all it does, and it never renders any text, and there's nothing to it. Or you can have like a full-blown component. And it can have everything in it. It can have JavaScript, it can have, so like here, it can have custom attributes, it can have custom event listeners, it can have custom CSS, like the whole 9 yards, right? And so the intent would be something like this. If you wanted to have a Twitter button that you could just put anywhere, you just use this custom element or web component, and it knows how to style the button, pull the right icon, make sure it's the right colors, make sure it's the right size, make sure that the right event listeners like click and whatever are on it, all that stuff. So I'm just going to kind of leave it there. I'm not going to get too much deeper into what web components are. Feel free to look it up yourself. There's tons of information out there, but I think it's in my personal opinion, it's the future. And I really believe that there's that components like this are going to be a very standardized way of doing things. These are web components are W3C specified, which means that all the browsers are going to end up down the line supporting them in one way or another, which means that, yes, you can make the argument that frameworks like React and Vue have a similar aspect to it. But again, I want to avoid the frameworks. I want to be learning about the raw bare metal stuff of what I'm working with, because I feel like that it empowers you to understand frameworks even better, because you understand what's under the hood of those frameworks. So we're going to stick to the raw browser-based elements here of web components. So I'm going to say web components. I'm going to use vanilla.js. I'm not going to use any other framework. We'll go with TypeScript, because what we can do is we can compile TypeScript into ES5, ES6. So that should give us IE11 compatibility. We'll use polyfills only when necessary. And then just kind of jump back to TypeScript. If you don't know what it is, TypeScript is basically a type-driven compiler for JavaScript, transpiler, I suppose you could say. Essentially, you write code in Java. You write code in TypeScript that is very, very close to current JavaScript standards. And then TypeScript does things like making sure that a parameter properly accepts a string or a number, which is something that's really malleable in JavaScript in general. So with TypeScript, you get to like be really granular about your code if that's what you want to do, and avoid a lot of problems. I've used TypeScript on production environments in the past, and it has saved my bacon, and I can't say enough about it. I will use it for this. You guys can make up your own minds. Again, I won't get too deep into it. You can have a look for yourselves and kind of sort it out. Okay, so yes, TypeScript with vanilla.js, that should give us, we can also do, we can compile down to ES5, which should give us IE11, hopefully. I do see some caveats there, but we'll deal with it when we get there. All right. What else? I would like to use atomized or atomic CSS. It's a framework called Tailwind. Now, I know this goes against my no libraries or frameworks. However, this is one exception I will make, and the reason for this is because Tailwind gives me an atomic level CSS that I don't have to rebuild, and I wouldn't rebuild it any differently. Anything that's in here is so atomic that it's almost one for one what I would do in CSS. So by using this framework, I am actually learning what the core CSS underneath is for the most part, aside from maybe media queries. I would say only media queries are the things I'm not entirely learning here, because it does some media query resizing for me. But we can actually do our own media queries, which we'll do. We will probably have to write our own atomic CSS, so we'll get to learn that. This will just save us a little bit of time doing things that are not going to really benefit us in terms of a learning experience. So I'm going to stick with this. I'm sticking with this decision. We'll see how it works out. Maybe this will be horribly wrong, but yes. Atomic CSS also is, like, if you compare it to something like Bootstrap, right? 4. I think 4 is the latest. Maybe it's 5. Let's go here. Yeah. So what Bootstrap does is it gives you a bunch of components already sorted out, and it's not atomic. So all of, like, assigning the color blue, for example, sometimes with Bootstrap and other similar CSS frameworks, the color blue is like a default assignment of a specific component. With atomic CSS, you have to be more declarative. So you have to say, a class has to contain margin top 1, margin top 2, and it's got to have a default color of blue unless it's on hover state, and then it's got a default color of red or whatever. It seems tedious, but I think for components, and especially for web components, I really do believe in this method. Now, I'm going to stop there. I won't explain much more. I encourage you to look into it, and you'll see the utility behind it as we use it in what we're doing here. So let me just... Okay, gotta answer that. Okay, so I'm going to stick with that decision. We can sort out some of the details. You'll see why later. It's kind of a difficult thing to explain up front anyways. Okay, so we've got some atomic CSS. I think what's going to have to happen for the online version, I'm going to have to go PHP. For the couch co-op, I'm going to have to go Node. And I'll explain why. I want this to be cheap and easy. In order for that to happen, I need to try and fit within the constraints of my hosting provider. So I'm going to show you. Here, let's go here. So I use SiteGround, and they offer like pretty good pricing for domains and hosting. I have the startup account, and I'm going to create a subdomain on my main website, which is spirofloropoulos.com. By the way, that's my name. I'm Spiro. I should have said that from the outset, like the spear. Okay, so I have this account. I have hosting, and that's great. But there is a where do you go? No. There are details here. There's a restriction. Oh, SiteGround hosting plans comparison. Here. Okay, so here's what I have to work with, right? I don't want to be paying an arm and a leg. I need to stick within the constraints of my hosting provider. And here's the problem. See this CPU seconds, third list down? That CPU seconds thing is the problem. Because as you can see, I have a limit on executions of CPU seconds per hour, which is 1,000 CPU seconds per hour. What are CPU seconds? CPU seconds are hits on the server for compiled or for what am I trying to say? I'm having a hard time with words here, guys. This isn't even the right one. I'm sorry, guys. Bear with me. Okay, here. CPU seconds. An execution is when a visitor opens your website and your index.php file is loaded. This counts as one execution. The more visitors your website has, the more executions it will take. Please note this is valid only for dynamically generated content. If you open a picture or an HTML page, a new execution will not be generated. Executions are counted for the following scripting languages: PHP, Perl, Python, Ruby, etc. So executions count towards your CPU seconds, because the more you have to execute, or the longer something takes to execute, the more CPU seconds you eat up. So this is the problem with, I'm purposefully working within this limitation so that we can work through this process together and really try and get to the nitty-gritty. So I can't possibly have it wouldn't be good for me to have a system that eats up a lot of CPU seconds, first of all. Second of all, SiteGround, the startup account, does not have Node available. SiteGround shared hosting plans do not support Node. You'll need a dedicated server with root access. So it says do not support the latest Node. It's possible that we could do something with an older version of Node, but I have to assume that the version will be so old that it's not worth it. I could look into this, but again, I'm purposefully choosing not to, because I want to work within a constraint here so that we can tackle problems like this. Like, you're going to experience problems like this in the real world, so let's sort it out, right? So PHP comes packaged in the startup hosting account. I need to keep my executions in check. So that's why I am saying PHP for the online version, which will end up on SiteGround. And then couch co-op node, what do I mean by that? Well, what I think we can pull off, and I could be wrong about this, so we'll see. What I would like to try and pull off is a version that you can run very simply, kind of like any other game. You just double click on an exe file and it runs a node server on your machine, and you can have participants, like maybe on your phone, join in as long as they're, say, on the same Wi-Fi. Honestly, that might be a bit ambitious, but I'm not taking it off the table. I would like to give it a go. I want to see how far we can take it. There's a possibility, I haven't thought this through, that I might want to use a Qt GUI up front. And what I also hope to do is cover Android and iOS by implementing a PWA. What is a PWA? It is a progressive web app. So let's get rid of that. So a progressive web app is basically an app that can more or less function natively. It kind of fakes it. You can actually install it on desktops and mobile platforms as if it was an app on your phone. And it pretty much behaves like a native app. Not 100%, but it's pretty close. iOS lags behind, but I think we can work around the iOS limitations with what we're doing here. I won't go too deep into the different aspects of a PWA app, but I would recommend that you look it up and see for yourself what it's like. And you'll see how we try and implement it as we work through it. But I think this would probably be a good approach just to kind of get the ball rolling, to cover both aspects of iOS, Android, and online. And then that way it's just one code base, or pretty much one code base. And so then your PWA app would connect to the SiteGround PHP online version if you're doing online multiplayer. And it could potentially connect to the Node version if you're running a home Node version, which you can do couch co-op. I am also going to be really ambitious here. I mean, this is kind of going a little crazy here, but WebRTC, it might allow for pure mobile to mobile multiplayer with no server. If you don't know what WebRTC is, it's a new set of browser standards, somewhat newer. I think it's pretty decently supported. And you can even do like web torrents. Like you can do torrenting on your browser. So you don't need a desktop version of a torrent. You can do peer-to-peer communication. And you can do it such that two people pass a key to each other and you're both connected without any server, any external server at all. It's just peer-to-peer on the browser. Again, I'm not going to go too deep into it. I would recommend, again, that you look it up. But I kind of have this gut feel that it might be possible to create a no server multiplayer server, a serverless server, where perhaps one of the peers acts as a master, and the others are connected to it. I haven't thought that through, but we'll see. We'll see where this takes us. As you can see, I mean, this is going to easily be 40, 50 hours of work. Easy. Super easy. But this is the kind of stuff that's not on YouTube. You don't see these long form videos very often where somebody takes, days, weeks to work through a project and kind of takes you through the process of it. I know there are some, but I think you find more, I don't know, watered down. Here's the basic concept, and I'm trying to be aggressive and learn a lot with you guys. So this might seem like, daunting, overwhelming, but we'll break it down and we'll tackle it one step at a time, and we'll do some MVP stuff, which is minimum viable product, and we'll just take bite-sized chunks out of it and we won't get overwhelmed. Okay, let me take a sip of coffee here. Okay. I think I need to stop myself. I'm not going to tackle any more technology decisions. I think we have enough to get us started. So now the key question is, what is the MVP? What is the minimum viable product? Actually, I have one more. Sorry, guys. I have one more thing. Finite state machines. I encourage you to look that up. The benefit of a game like Koro is that there are a particular set of states that the game can be in, and it's pretty well defined, as a pretty good chunk of board games are. You have constraints, you have boundaries and rules, and you have to work within them. So a finite state machine is a declarative way to say these are the available states and transitionary states, meaning moving from one state to another, of this application. They have saved me. I cannot count the number of times that finite state machines have saved me. And I think they actually fit in well with web components, because if you take an HTML component and you break it down into a bite-sized piece, the number of states that component can be in is pretty finite. And you can very declaratively say these are the states that this component should be in at any given moment in time. This is all you can do with this. And then you plug all of these things in, and you can build kind of like a controller component with its own set of finite states, or perhaps a malleable set of states, in which case maybe a finite state machine isn't the right tool to use. We'll try our best to use the right tools for the right job. But I did want to specifically call that out because I love using it, and I think this fits in well with the board game aspect. Finite state machines are also integratable as code. So by writing out the state of an app, you can actually write it out in code form. So we'll use it in JavaScript and PHP, and you'll see that there's actually a way to implement what you've written out directly into code. It's kind of like converting pseudocode into actual code. I'll stop trying to explain it. You'll see it as we use it, but again, recommended that you look that up and see what it's about. Okay. MVP, minimum viable product. So we've taken on a lot here. It's going to be very easy to get lost. So I apologize. That went down the wrong tube. I can't breathe. Okay. I'm just taking a moment to think this through here. So, because like I said, I have purposefully avoided thinking about this too much. So I don't want to take on too much. I want to build out a simple PHP server that that allows two people to play the game. I need a way for that server to accept user actions like rolling the die, buying a card, etc. And I need a way to serve that information back to the user so that I'm not using up my hosting provider's CPU seconds, CPU counts. What I don't want to be doing is, in order to avoid using up all my CPU seconds, I can't have a long-term connection. So sockets are kind of out of the picture, like WebSockets or long polling. Because if I'm long polling a PHP or a Node service, that's just eating CPU seconds. So for the PHP version, I can have a REST API because it means atomic requests that I can control. And on the client side, AJAX functionality or XHR requests to my PHP server only when the user needs to take an action. In order for everyone to stay in sync, since sockets are kind of out of the question for the time being, you'd want to continuously ask the server for the updated state of the game. That's a problem too, because if you do something like every 5 or 10 seconds ask the server, you're making a PHP request and that's going to eat up CPU seconds. Multiply that by many players, you're going to eat up 1,000 CPU seconds in no time. You'd have like, what, 20, 30 players online? I mean, that's not terrible, but... Okay, so it would be, if static pages with no processing don't count towards CPU seconds, then maybe what I can do is have the PHP server or the PHP service accept user action requests, respond with a success or fail, and all the players continually request for the updated state of the game, but they don't request it via a PHP request. They literally check a JSON file that holds the current state of the game, and the JSON file is maybe timestamped or unique ID'd to the game in question. So you could pull that as many times as you like and it wouldn't count towards CPU seconds. It might count towards traffic, which I'm not entirely sure that there's a huge limitation on that. But traffic probably counts as CPU seconds. Does it? Yeah, it doesn't seem to. Yeah, they just convert CPU seconds to approximate visits per month. Okay. Okay, so PHP will serve API requests with success or fail. It will also generate a JSON file, one per game, with the current state of the game. The JSON file will be uniquely named for the game being played, so there's a way to identify that this is the game you're playing. We'll just say above allows for unlimited requests. Above allows for unlimited requests. without SiteGround restrictions, basically. My wording sucks, but... And then client will, or I guess player, will make user action requests against the PHP API. And client player will continuously ask for game state by requesting a specific JSON file. JSON file may include full game state in all its glory, which means like all the players, everything that's currently on the board or on the table, all history, all data, everything. Or JSON file may just be initial game state plus action log or action audit log. There's a thing called event sourcing, which is kind of what I'm alluding to here, which is that instead of doing a direct change to a model of some kind, you have an initial model and then somebody takes an action that's intended for that model and you record the action. And then you subsequently build the model based on the series of actions that have taken place. So if somebody has a bank account and your model is what's in the bank account, maybe the initial state of the bank account is $0, and then somebody adds $10 to it. You don't add $10 to the model. You create a log or an action that says $10 added to bank account. And when you go to pull the model is the equivalent of the initial model plus action, which is adding $10. I can't clearly see a discernible path to this yet, which is fine. We have options. So we can do an event sourcing, kind of what I described just now. We can do a little bit of both maybe with the game, or when you request the JSON file, it includes the audit log and it includes the updated game state. That might be too much. What I do like about the audit log in this particular instance is that in a board game, if you want to debug something, having an audit log allows you to roll back and replay things. Not entirely roll back, perhaps. Roll back might be too much. What you might be able to do is take an initial state and replay it. Yeah, that seems right. That might actually save us a bunch of time debugging. And then what you could do is maybe, I'll just put a question mark around this. Like let's say you're a player and the game takes days, and so you've logged off, so you no longer have the current game state in your browser. When you rejoin a game, you get a latest snapshot plus latest actions. Okay, this is questionable. I think probably we should just leave this for now. I think we've done too much. So here's what I'm going to do. Potential, I don't know, adaptations. Adaptations. Had to say that out loud. Yes. Yes. Okay. I think this is it, guys. Little to no UI. Why? Why am I saying that? Because the UI is something that we can add on once we have the finite actions of the game more or less discernible to us. I don't think we need to spend time on the UI as an MVP. I think what we need to demonstrate is that we can serve a PHP app that will allow us to play the game. That PHP app can generate a JSON file that is, for the time being, the entirety of the current state of the game, and that a client on the browser can request the state of the game and take actions against it. So maybe we'll say little, or maybe we'll say basic UI, just to like to take actions and see states results. Like, super simple. This is just to kind of get a visual picture of where we're at. Okay, I think that's good. That means that we don't currently need, we'll probably need like a, I just thought of this, MySQL for authentication. But for right now, no authentication, just two-player defaults. Yeah. Yeah, MySQL PHP for authentication on online service. I'll put that, yeah, I'll leave that as a question mark. I'm not entirely sure, but it is something to consider. Yeah. And then there, down the road, there will be performance client, performance, general performance considerations. Like web components, if you want to have like a really smooth, streamlined UI where you're, playing a board game on your browser or whatever, performance is going to matter. There are things that React does, for example, like with the virtual DOM thing, look it up again, that help make something feel performant as you're using it. We might run into those issues as we're trying to like do something that's smooth gameplay, or as smooth as we can get it. We'll cross that bridge when we get there. Let's just stick with the basics for now. So I think that's good for this episode. It's a starting point. We have a path. We know we have to build a PHP service. We know we have to build some form of client-player UI system to interact with a PHP service. And we know that we want to have a JSON file that represents the current state of the game so that we can call it as much as we like. And then that way we can kind of fake a real-time interaction. Even though it's not real time, there isn't a WebSocket or a constant connection, we could do every second or something. We can sort that out. That feels like a decent start. Okay, so I'm going to commit this, and then what's going to happen is on the next episode, we'll get down to planning what the initial PHP service is going to handle. What kind of requests, what will it generate? How will the client connect to it? Like just some of the basic things. So it's possible that we won't actually get into any of the heavier lifting until episode 3. Episode 2 might just be a lot of setting up a REST API service, which is probably what I'll do. And connecting to it, using it with Ajax, XHR, setting up, an initial TypeScript system. Yeah, there's going to be a lot of setup. We'll have to use Composer, initialize TypeScript, initialize Composer, initialize some base classes in PHP, make some basic API calls, put it up on SiteGround, set up a subdomain for it, make the call to the subdomain. Yeah. So I wouldn't expect anything too serious until episode 3, but the next episode will cover setting everything up and getting going. I think that's it. I think that's a good start. We've spent, it looks like, close to an hour, and that time I drank it correctly. And hopefully this has been helpful. I want to emphasize that this is something that is really important when it comes to tackling projects in the real world in production. I also didn't do my markdown right. I'm just thinking I really did not use markdown correctly. I might make some changes when the video is done. In any case, at least half your battle will probably be thinking before you do any code. That's not always the case, but from my experience and from the experience that I understand others to have had, thinking is at least 50% of being a programmer. You have to build kind of a structure and a world around you and then kind of sort that out before you put code on your IDE. So this is all part of the big picture. It is this pre-planning, thinking things through as much as possible process. So there's going to be a bit more of that coming. And again, like I say, I'm going to try and verbalize a lot of that, and hopefully that's helpful to you guys. I'm going to end it here. Thank you for watching. Constructive criticism is warmly welcome. If how quickly I do the next episode will depend on you guys and how much you mash that like button, if that's what you want to do. Reach out to me with questions or suggestions or whatever. If anybody out there is a kind of design UX person and would like to assist me in this endeavor, because that's not really a strength of mine, please do reach out and maybe we can collaborate with the video. And it might be kind of cool to show in this process what it's like to have, someone programmatically minded working with someone design minded, and how the two get put together and how you interact with someone like that. Yeah, I think that would be good. Okay, that's it for me. Thanks again, guys. I really appreciate the support. Any support you give would be great. And we'll see you in the next episode.